Hey everyone, we are excited to be here today to talk about something that affects almost everything around us: business, wealth, and even social media trends. But before we get started, let's introduce ourselves. We are the Team Microsoftires, and we have two partners today: Shekhar Lamichhane and me, Samyam Shrestha. Together, we'll be walking you through the fascinating world of Pareto distribution, also known as the 80-20 rule. But let's start with a quick question. How many of you have noticed that a few things in life seems to make the biggest difference? Maybe in your studies, where 20% of the syllabus gives 80% of your exam questions, or even in gaming, where a few strategy help you win most of the time. Well, that's what exactly is the Pareto distribution. In this video, we will be diving deep into the following topics: introduction to Pareto distribution, the parameters, application in various fields, the code implementation in Python, limitation and challenges, and finally, the summary and the final thought. So let's get started with the video. First of all, let's begin with what Pareto distribution is. The Pareto distribution is a mathematical concept that describes situation where a small number of things can create a huge impact. But where did it come from? The term Pareto distribution is named after Vilfredo Pareto, an Italian economist who in the 80s observed that 80% of Italians' land was owned by just 20% of the population. That's what gave him the motivation behind this whole distribution thing. This pattern appeared everywhere: in business, in wealth, and even in nature. Let's take a real life example. The first example, the wealth distribution. A small group of people hold most amount of country's wealth. Second being business scale. 80% of profit often come from 20% of product. And in social media, a few viral posts gets most of the likes. Let's take a moment. Can anyone think of any other example where a few things have biggest impact? Let me know in the comments below. Now, let's break it down further into two main parts: the parameters. Here are two parameters: the scale parameter and the shape parameter. First, scale parameter. This is the minimum value in the distribution. Think of it as a starting point. And in the shape parameter, this controls how steep the distribution is. The higher the alpha, the fewer the extreme value. If alpha is low, you see more extreme values, and if it's high, the effect is very small. Did you know that in most companies, 80% of the work is done by just 20% of the employees? Here are some of the formula that's very important in Pareto distribution. Moving on to the applications of Pareto distribution. Why does this even matter? Because businesses, governments, and scientists use it to make important decisions. Some of the major application of Pareto distributions come in wealth and income. Most of the money is owned by a fewer individual, and business and scale. Companies use Pareto analysis to focus on their best selling product, internet and network traffic. A small percentage of website get most of the web traffic. Gaming and sports. A few elite players win most championship. If businesses and policymakers understand this, they can make smart decisions. Instead of trying to improve everything, they can focus on what gives the best result. And instead of just doing it manually, we can use Python. Here's a simple implementation in Google Colab. Here in the given code, we have first imported the required libraries, and then we have declared the parameters, the scale parameter and the shape parameter. And then we generate the Pareto distribution random variable. And after the generation is run, we have calculated the PDF. And after the calculation is done, we have simply created a histogram of the sample data. After the creation of histogram, we can even calculate the mean and variance. Here in a graph, it shows how a Pareto distribution dataset looks like. Notice how the curves have steep down at the start and a long tail. That's the feature of this distribution. Let's get deep into the interpretation of histogram. This is right skewed distribution. The histogram shows a typical Pareto shape with most data points concentrated at lower value and a long tail extended to the value. Histogram versus PDF. The sample data histogram closely matches the theoretical probability density function, indicating accurate representation of Pareto characters with the parameter that are affected. The scale sets the minimum value and the shape parameter influence the distribution steepness, resulting in the moderate trial. Mean and variance. The mean is calculated for alpha while the variance doesn't exist, as alpha must be greater than 2, highlighting the limitation in the measuring spread. So let's get moving to the limitation of Pareto distribution. Of course, no model is perfect. The Pareto distribution also has its drawback. Firstly, it is sensitive to outliers. A few extreme value can distort the result. The second one is it's not always accurate. Some datasets do not fit the Pareto model. And the third one, mean and variance, doesn't always exist. If alpha is too low, we cannot even calculate these. So while the Pareto principle is useful, we have to be very careful when applying it. So let's conclude today's lesson. So what did we learn today? The Pareto distribution describes situation where a small number of factors contribute to the larger effect. It's useful in business, economics, social media, and even in nature. It has some limitations, but when used correctly, it helps us focus on what really matters. Next time, when you notice that just a few things make a big difference, whether in gaming and studying, or even choosing which Netflix show to watch, you'll know it's Pareto effect that works. So, thank you everyone for your time. You guys have been a lovely audience, and we are happy to take any questions regarding Pareto distribution. Let us know down in the comments.